Welcome back to my video. I am Anusha of CSC department, working in Institute of Aeronautical Engineering as assistant professor. So in my videos, I was discussing about programming with objects. It is a subject dealing with Java. So in the previous video, we have discussed about abstract classes and methods, packages, what is class path, and how to import packages into a program. Now in today's video, we will be discussing about interfaces and default and static methods, defining interfaces, how to define an interface, how to implement them, and what are the use of default and static methods in an interface. So let's move on. In our previous video, we have seen about achieving abstraction using abstract classes. So abstract classes, they were not providing complete abstraction. But using interfaces, we can achieve complete abstraction. We can achieve 100% abstraction using interfaces. So the methods, so in an interface, we will have abstract methods, and those abstract methods must be implemented by the class which is implementing that particular interface. So for example, if we have an interface, and we have some method, say A in it. So this will be abstract. That means this method will not have any body which is defined inside the interface. So the body of the interface, the body of the method available in the interface has to be defined by the class which is implementing it. So this interface will be implemented by some class, say class A. So this method which is can be available here also in class A. So class A must provide the implementing body of the according to their requirement. The class A can provide its own logic for this abstract method A. Now these interfaces are very similar to classes, but that they lack instance variables. They don't have instance variables. The interface variables which will be available inside the interfaces will be static. They don't have instance variables, but they have interface variables which are static, and also their methods will be declared without any body. They won't have any body for the methods. And so as I've told you, the body has to be provided by the class which implements it. The body will be provided by the implementing class. Then another advantage of using multiple interfaces, is that we can achieve multiple inheritance using interfaces. The reason is that Java does not support multiple inheritance using classes, because there comes a problem called as diamond problem. So what happens there is that, let's say, multiple inheritance is the ability of a class to inherit from more than one class. That is multiple inheritance. But Java does not support it. The problem is that, let's say we have a class A with method A, and we have another class A1 with same method name. So these two classes will not provide any implementation. These two classes will have their own implementation. Let's say these two classes are having their own implementation for the method A. Right? Now, we have another class B which is inheriting both from A as well as A1. So the method A, these two methods will be available here. Both the methods from A and A1 will be available here. Now let's say the object of B is invoking A. So what happens? Here, this object will have a confusion of which method it has to invoke. So this problem is called as diamond problem. So there comes an ambiguity in the method which it has inherited. So the object will have an ambiguity of invoking which particular method from which particular of which class. So that is the issue with Java in permitting multiple inheritance using classes. So to achieve multiple inheritance, they go for interfaces. So the multiple inheritance can be achieved in Java using interfaces. And also interface provide complete abstraction in Java. Now, once an interface is defined, this interface can be used by multiple methods, multiple classes. Many classes can implement the same interface. Similarly, one class can get one class can get interface from more than one interfaces, from multiple interface. A class can implement more than one interfaces. So that is again an advantage of using interfaces. Now, once an interface is implemented by a class, it is a duty of the class to provide the complete set of methods required. So the class must provide the complete implementation of all the methods which is available in the interface. So each class is free to define their own implementation. Like for example, if this let's say we have method A in this interface. So this is class A, this is B, and this is C. So A can give its own implementation, its own way. B can give its own way, and C also is free to give its own way of implementation. So the use of interface keyword implements one interface multiple method aspect of polymorphism. It also supports dynamic method resolution at runtime. But an interface cannot contain a constructor as it is not used to create objects. Now, this is the general form of an interface, wherein we have the access specifier, the interface keyword, and the name of that particular interface. We have the different interface variables which will be always initialized to some value and their data. Similarly, it can have many methods with many methods which are abstract, because of which, since they are abstract, these methods don't have any body. They always end with semicolon. So these all methods will be abstract. Now, the variables in an interface are always public, final, and static, and they should always be initialized. So since they are final, the variables which are the interface variables cannot be changed by the implementing class. Similarly, all the methods of an interface are public and abstract. The methods are always public and abstract. And also, the regular methods of the interface methods generally don't contain body, but the methods which are default and static in nature may have body. They can contain body. We will see the importance of default methods in the later point of time. Now let's look into the interface definition and implementation. So we have already seen the structure, basic structure of an interface. So here this is the interface keyword, and we are defining an interface named as callback. So this callback interface contains a method called as callback with some parameters passed, and this is an abstract method. So it is ending with the semicolon. You don't define any body for that. That body is not given for the interface method. Now, when you have a class implementing that interface, this particular interface, this is the general structure. So we have the class name for class keyword followed by the class name. Then extends any superclass if it is following inheritance, and then the keyword used for implementing an interface is implements the interface. So, for example, if in our it can have more than one interface is implemented, and the class body. So let's say, for example, we have this callback interface defined. That interface is being implemented by a class named client. So this is the keyword. The client class is implementing the callback interface. So since it is implementing the callback interface, it has to provide the implementation or the body for that callback. So this client class is defining the callback method. It's defining the callback method in its own way. This is one way of implementing the callback method by client class. Now, if there is some other method, some other class which is inheriting callback interface again, it can give its own implementation for that method callback. So this is how we define and implement an interface. Now let's look into an example. So here in this example, we are creating an interface to find the area of a rectangle. So here we have the area of the rectangle. We are defining an interface named as find area, and there is a method area1, which is the abstract method of that interface find area. So whichever classes inheriting the find area has to give the implementation for this method area1. Now we have the class rectangle2, which is implementing the find area. So this rectangle class is having its own variables, instance variables, two integer instance variable L and B. And the constructor is a parameterized constructor which will initialize the values of the length and breadth to some values which is passed to it. So whatever value is passed at the time of object creation is being used and initialized over here. And then we have the method area1. The body for that is defined over here, which is displaying some statement and finding the area and returning that value. Now inside the testing or the main class, we have the main method. Now we are creating the interface variable, interface reference variable FA. So here we are creating the FA is the interface reference variable of find area. Inside the main class, we are creating the reference variable for the interface, and using that reference variable of the interface is accessing the object of that rectangle class. So when you call this statement here, when this part is executed, the constructor will be invoked and it will create a rectangle with length 3 and height 5. So an object for that rectangle will be created with length 3 and breadth 5. So here we are making use of the interface reference variable to access the object of rectangle class, and using that same thing we are invoking using the interface reference variable, we are invoking the area method available. So you get once this is invoked, you get these two statements in the output. So it will pass 3 and 5 here. 3 and 5 will be set here, 3 and 5, and that value will be retrieved, 3 and 5. Its product will be computed and that will be returned over here. So that value will be displayed as 15. Now similarly here, this is the normal invocation. We are creating an object for FA. We are creating an object of the rectangle class, and we are invoking area1. So the point to be noted here is that we can make use of the interface reference variable to point to the object of that particular class. So in the second case, when the object is created, again another object will be created, FA1, with the 3 and 5, and it is calling the area. So it will display the second two lines of the output. So this is how this is the working of interface. So we'll have an interface, and that interface will have some method, an abstract method which don't have any body, and that method should be defined by the class which is implementing that particular interface. Now let's look into how to make use of this interface reference variables in one more example. So in this case, we have the method callback. This interface's name is callback. It is having a variable named v, which is initialized to 10. This should be always initialized to 10. And these are all final, static and final. And we have the abstract method callback with some parameter passed to it. So let's look into accessing implementation through interface reference variable. So we have an interface named as callback with a variable named v, which is always public and static, and we have an abstract method callback with some parameters. So we have this interface callback, and it is having the method value v, which is 10, and the method callback defined. So this is our interface. Now from this interface callback, a class named client is implemented. So since client is implementing this callback interface, the method callback should be given some body. So that method is defined inside the client class. So we have the client class, which is giving some body for the callback in its own way. Okay. Then we have another class client2. I have another class client2, which is again implementing callback. So from that interface callback, we have client1, class client1, client2. This client2 is having two methods. One is the interface method. So it is giving the body for the interface method callback, and the client2 is having its own interface method. Sorry, its own method, non-interface method. This is the member method of the client2 class. So and we have some implementation for that. So inside the callback, it is displaying the value of v. Inside the callback, client2 is displaying the value of v, and inside the non-interface method, it is again displaying the value of v. So this client2 can have so any class which is implementing any interface can have its own member methods also. It is not that it should only have the interface method. They can the classes which is implementing the interface can have its own member methods too. So we have the client2 is having the callback method and the non-interface method. So client2 class is having two methods, which one is the implementation of the first the interface method, and second is the member method of client2. Now again, we have another client. Another client class, which is again implementing the interface. So from that interface callback, we have three classes implemented. One is the client1, then you have the client2, which is having this will have callback only. Here it is having callback and non-interface method. And another client is having, it is also giving a different way of callback method. It is a different way of implementation for the callback method. So inside the another client, how is the implementation? It is displaying the product of the value which it has taken. It is defining the square of that value which is being passed as the parameter. So this implementation is a different way of implementation inside the class another client. Now we have the test interface class, the main class. We are creating two interface reference variables, C and C3. Now C is made to point to the client object. C is made to point to the client object. And we are invoking callback 42. So we are passing 42 to the client2. So inside client2, this is the implementation of we are making the C point to client class object. So and then it is calling the, C is calling the callback of client class. So it will invoke the client class callback method, wherein this statements will be coming in the input. So these statements will be coming into the input. So we get client object callback called with 42 and value of v as 10. Now we have another interface reference variable which is made to point to the client 2. So when you now C3 is, we have the client 1 object, client 2 object, and another client object. We have C1, C and C3. C was initially pointing to C1, sorry, not C1, C. And when you call C dot, this is client, this is client 2. And this is another client. So initially C was made to point to the client. C reference variable is point to client. So when you call C dot callback, this will invoke the client class callback method. Now in the second case, we have C3, which is an interface reference variable. It is pointing to the client 2 class. So inside client 2 class, we have the callback method as well as non-interface. We have the non-interface method also. So when C3 is pointing to the client 2 object, it can access both these methods. So when you call, now we can try to, now C3 is invoking the callback method. So now C3 is pointing to the client 2 class. So you get these statements in the output, client 2 object value of 10. Now, since client 2 is having this method also, non-interface method also, when we try to access the non-interface method using the callback reference value, it will throw an error. It is not the interface reference variable is not allowed to access the member methods of the class which it has implemented. That means C3 cannot, this non-interface method is another member method of client 2 class. Now when this access is not permitted because this client the interface object can only access the interface reference variable can only access the methods which is defined inside the interface. It cannot access the methods which is defined inside the class the class which has implemented that particular interface. Because here we have the client 2 class which has defined the client 2 class has implemented that interface callback. So this client 2 class will have the callback method as well as a non-interface method. The object of client 2 can access the object of client 2 can access the callback method as well as a non-interface method. But if we are using the interface reference variable to call the non-interface, the member methods of that particular class, that operation is invalid in Java. Okay, so this statement is not allowed. It will throw an error because we are trying to access the using the interface variable. We are trying to access the method of the member method of that particular class, which is not allowed in Java. Now this is we are creating the object C2. We are creating the object C2 of client 2 class, and we using the client 2 class object, you can access both the callback method of client 2 as well as the non-interface method of client 2. This is the regular way of using it. But using the interface reference variable, we cannot access the member methods of that implementing class. Now again, we are creating an object of another client. C was initially pointing to client. Now we are removing that and we are making it to point to the another class, another client object. Now C is pointing to another class, another client object, and we are invoking callback. So in this case, it will invoke since C is pointing to the another client object, this method will invoke the callback defined inside the another client method. So we get inside another client method, we have the statements, another version of callback, square is, the value of V is displayed. So we get another version of callback, square is, and the value of V as 10. So this is how we access the implementation or the implementation methods using the interface reference variable. So the point which we have to note over here is that using the interface reference variable, we cannot access the methods which is defined inside the implementing class. The member methods of that particular class cannot be invoked. Only the interface methods will be visible for the reference variable of that interface. So that is the main point to be noted over here. Next, let's look into the default and static methods. Now, let's look into a scenario. Let's say we have an interface I, okay, and this interface is being defined by, say, hundreds of classes, okay. This is class 1, class 2, like we are having 100 classes which is implementing this interface. So, the method inside that interface will be given some implementation over here. Every class which has implemented the method, the interface I will provide an implementation for that particular class, right? So now let's think of, at some point of time, we wanted to change this particular interface and we want to include one more method to it. Let's say we have the method J to be provided for this interface. So what happens? All the class, since when J is included in this interface, all the classes which is implementing that interface will have to implement J method also, right? It has to implement that J method. So what is happening here? When you include this method J into this interface, all these classes will be broken. All these classes will be broken and some error messages will be thrown onto, will be displayed in these classes. Because whatever method is available inside the interface must be defined by all the classes which is implementing it. So we have, if the project is huge project, then whatever class is being inheriting that particular interface has to give the implementation body of that particular method, which is a hectic task, which is very difficult to achieve. So to prevent that, they have come up with the default method. So to prevent that problem of breaking down these classes, they have come up with the default methods. So inside default method, so when you define any method with default keyword, then that error will be only those classes, only some particular class may need to. If we define that that method as abstract, if we define that method as default, then that error messages will be solved. It will not have any error message. And since these methods are defined as default, they are allowed to have some body of its own. These methods can have these default methods. So we define J method as default. So since J method is defined as default, these methods can have body of their own. They can have its own. This method J, this default method J can have some implementation body for inside the interface itself. So that is the advantage of using default method. So it prevents it allows the interface the default methods the default methods inside the interface can have body, and it prevents the breaking down of the implementing classes. So if we want to add new methods to an interface that are automatically available in the implementation, we make use of these default methods, and hence we need not modify the implementing class. So and similarly, we have static methods also, which this static method also can have body inside the interface, and they also can be used by the name of the interface. So interface name, for example, if that interface I is having a static method j, then we can call it as i.j. That method can be called using the name of the interface followed by the method name, same way how we invoke the static methods of a class. So let's look into an example. So we have the interface IF1, wherein it is having two variables a and b, a double variable a which is initialized and a int variable b which is initialized to 20. Now we have the static method. So since static methods are allowed to have body, we are giving some body to it, which is displaying the statement, and we are trying to access the interface variable a and b. Since a and b are both static, we can access them using the interface name. Since this static method is accessing another static method b, we can directly call them instead of using the class name. So here now we are looking into the explanation of default and static methods. So we have the interface named IF1. It's two variables, one of double which is initialized to 10 and another of integer which is initialized to 20, the variables a and b. It is having static method and a static method and a default method. So they both are given body. The both static method and default method is given body, and the normal methods of the interface doesn't have the body, which is abstract, and they has to be provided by the class which is implementing it. So now inside the static method, the implementation is like this, which is displaying the statement, and it is trying to access the variables a and b. Since this method is static, it may or may not use the interface name. So these two variables can be accessed with the interface name and without interface name, because there is no issue in accessing the static member accessing another static member. Now we have the default method. Inside the default method, we have some, this is the implementation with some statement displayed, and it is trying to access the static members of it interface. So we are using the interface name along with those variables, and we have the regular method which don't have any implementation. That has to be given by the class which is implementing the implementing that particular interface. So we have the class Pegasus which is implementing the interface IF1. So Pegasus must give the body for that body for that method, regular method of the interface method. So here we are providing the body, which some statements, and again it is trying to access the interface. It is trying to access the members of that interface. Next we have the main method. Inside the main, we are creating the object of that class, and we are invoking all the three. Methods. So here, when you call this default method, the implementation was to display the statement and display the contents of A and B. So we got that. Then it is invoking the regular method. So we have the regular method body given like this, that is being displayed, and the values of A and B are displayed. And similarly, we have the static method, which is which is displaying the static method in the interface. It can have body. Sorry, this statement is not needed there. So yeah, it is not needed there. So it is displaying the values of A and B. Okay, so this is about default and static methods inside interface. So we make use of default method for achieving we make use of these default and static methods so that we can provide body to the methods, as well as if also prevent the breaking up of the classes. So that is all about default and static methods. Next, let's look into the interface variables as final and constants. So we can use interfaces to import shared constants to multiple classes by simply declaring an interface that contains variables that are initialized to desired values. And when you include that interface in a class, all those variable name will be in the scope as constant. So if we have an interface with some interface IF with some constants, with some values into it initialized, and this interface is being implemented by some class, then that class, these variables act as constants into that interface. So if we want to make use of any shared constants, we can create an interface with that number of constants, with that number of variables initialized to some value. So that is all for today's class. So to prepare this slide, I have made use of the textbook complete reference and these websites, Oracle Java tutorial and Java T-Point. And so in today's class, we have discussed about how to define an interface, how to implement an interface, and what is the importance of default and static methods. So that's all for today. Thank you for watching my video. We'll continue in the next session. Thank you.